Hey there, you've heard the name Python and thought, wait, are we talking about snakes or code? Well, today we're diving into Python, the programming language. So, in this video, we'll cover Introduction to Python, comparison with other languages, tools required, Python's syntax and style, variables, data types and comments, operators, memory management, conditional statements, looping statements, functions and built-in functions, and finally modules. So, let's jump to the introduction. Python is a programming language that's super popular, easy to learn, and kind of a big deal in the tech world. It's like the English of programming languages, super clean, no weird symbols everywhere, and it just makes sense. Fun fact, it's not named after the snake. Python was actually named after the British comedy show Monty Python's Flying Circus. Yep, the Python creator, Guido van Rossum, was a fan. Now, don't let its simplicity fool you. Python is powerful. It's used for web development, data science and AI, scripting and automation, game development, even building robots. Basically, Python is everywhere. And the best part, Python is beginner-friendly. You don't need to worry about curly braces, semicolons, or other scary syntax. Big names like Google, Netflix, Instagram, NASA, and Spotify all use Python in some way. So yeah, learning it is kind of a big deal. Alright, so you've met Python. But there are plenty of other programming languages out there too. It's kinda like choosing between pizza, burgers, and sushi. They all get the job done, but in different ways. Let's start with the OGs, C and C++. These are super powerful but kinda strict. You have to tell them everything. Like, hey, this is an int, and no, you can't just throw a string in here. Python's more chill. It's like, I got this, don't worry about the data type, I'll figure it out. Next up, Java. Java is like the guy in a suit. Formal, structured, talks a lot, just look at the syntax. Python. It's in a hoodie and slides, straight to the point and easy to vibe with. Now what about JavaScript? Well, JavaScript rules the browser world. It's the reason websites pop, slide, and look alive. Python, on the other hand, is a back-end beast. It powers servers, crunches data, trains AIs, and automates your boring tasks like a boss. Each has its superpower, but if you're just getting started or want a jack of all trades, Python's an awesome pick. Alright, before we start writing some epic Python code, let's quickly talk about the tools you need to get up and running. First and most important, you need Python installed on your system. You can download the latest version from python.org. When you install Python, you also get access to idle, which is Python's built-in editor. It's great for quick testing, but we'll look at better tools for serious coding. Secondly, the code editor. You can use Python's built-in idle, PyCharm, or any other editor of your choice. But if you want to code like a pro, I highly recommend PyCharm. It's packed with powerful features that make writing and debugging Python a breeze. For downloading it, just Google PyCharm, head over to the official download page, and grab the installer from there. Now that we have our tools ready, let's see what makes Python's writing style so clean and lovable. In Python, indentation isn't just about making your code look neat, it's part of the syntax. Blocks of code are defined by how they're indented, not by curly braces like in many other languages. Like here, after the if statement, there are no braces to define the block, only proper indentation is required. So, no curly braces, no semicolons. Just indentation to show structure. Secondly, to keep Python code consistent and professional, developers follow something called PEP 8, which stands for Python Enhancement Proposal 8. It's a style guide that covers how to name variables and functions, where to add spaces and line breaks, how long your lines should be, and even how to format your imports. Following PEP 8 doesn't just make your code cleaner, it makes it easier for other developers to understand and collaborate on. Third, naming conventions. Python encourages clear naming like use snake case for variables and functions, Pascal case for class names, and avoid abbreviations that make your code cryptic. Now that we know how Python expects us to write code, let's dive into the building blocks of any program, variables and data types. Every programming language needs a way to store data, and in Python, we do that using variables. Think of a variable as a labeled box where you can store a value and use it later. Like here, name and age are variables. We're assigning the value techies to name and 25 to age. One of the cool things about Python is that it's dynamically typed. In other programming languages, you have to specify the data type of a variable, like int, character, or string. But in Python, you simply write the variable name and assign a value. Python automatically detects the data type. Like here, x is an integer, and y is a string. This makes Python very flexible and easy to use. Now let's explore the data types you'll work with in Python. First, numeric types. These are used to store numbers. It includes int, that is integer values like 5, -1, 1000, float, that is decimal numbers like 3.14, 0.5, complex, that is complex numbers like 2 plus 3j. Second, text type, that is string, which is used to store sequence of characters. Example, hello world. Third, Boolean type, which represents true or false. Fourth, none type, which represents the absence of a value, like result equals none. Fifth, collection data types. These types hold multiple values in one variable. It includes list, tuple, set, and dictionary. Let's go a bit deeper here. List. A list is like a dynamic array. It keeps the items in order and allows you to change, add, or remove elements, which means you can mutate them. So, its key features are that they are ordered, allows duplicates, and they are mutable. Let's look at the code. We're going to create a list called fruits. Notice that we use square brackets to create a list in Python. Now, let's add some elements to it, like apple, banana, and cherry. So basically, it works like an array that we use in other programming languages. To print any element, remember that the index starts from 0. That means 0 is for apple, 1 is for banana, and 2 is for cherry. So if we write fruits 1, it will print banana. That's how we create a list. Now, if we want to add a new element, we can use the .append function and write the element inside it, and that will add it to the list. If we want to change an element, for example, replace the item at the 0th position with orange, we just write fruits 0 equals orange. So, since lists are indexed, we call them ordered. Also, we can modify, add, or delete elements from them. Next comes tuple. A tuple is similar to a list, but it's immutable. Once created, it can't be changed. So its key features are ordered, allows duplicates, and immutable, cannot be changed. Let's see the code. We're going to create a tuple called dimensions. To create a tuple in Python, we use parentheses, that's the syntax. Let's add some elements to it. For example, I'll add 2 dimensions, 1920 and 1080. So just like lists, tuples are also indexed. So if we write print dimensions 0, it will print 1920. Now, let's try to modify it. This will raise an error, because tuples are immutable. Once created, they cannot be modified. Now comes set. A set is an unordered collection of unique elements. It removes duplicates automatically and is great for checking membership. So its key features are unordered, means no indexing, no duplicates allowed, and it's mutable, so you can add, remove items. Let's see the code. We're going to create a set called numbers. In Python, to create a set, we use curly braces. Now let's add some elements. For example, 1, 2, and 3. Let's also try adding 2 and 1 again to see what happens with duplicates. When we print the numbers set, you'll see the output only shows 1, 2, and 3. That means the duplicate values were automatically removed, because sets don't allow duplicates. Now, let's add a new element using the .add function. Print it, and you'll see the new item has been added. We can also remove an item using the .remove function. Just specify which item you want to remove. Print it again, and you'll see that 2 is now gone. Now comes dictionary. A dictionary stores data in key-value pairs, kind of like a real-world dictionary. The key is the word, and the value is the definition. So its key features are unordered, mutable, fast lookups by key, means you can access values by its keys, and last, keys must be unique. If you're familiar with JavaScript objects, then this structure will look familiar to you. Let's create a dictionary named person. We'll add some key-value pairs like name, techie, age, 25, city, New York. So this is our dictionary. Now, if you want to access a value, you can use the key. For example, to print the name, write person, name. This will print techie. If you want to update a value, let's say we want to change the age, you can write person, age, equals 26. Print it, and you'll see the age is updated. You can also add a new key-value pair easily. For example, to add an email, write person email equals give the value. Print it, and you'll see the email has been added to the dictionary. Next comes comments. So, what are comments? Comments are non-executable lines in your code meant for explaining what's going on. They're ignored by Python, but very helpful for humans, especially future you or other developers reading your code. So for adding a single-line comment in Python, simply use a hash symbol at the beginning of the line. And for multi-line comments, you can use triple quotes. Now jump into the operators. In Python there are 6 types of operators: arithmetic operators, assignment operators, comparison operators, logical operators, identity operators, and finally membership operators. Let's see what they are. Arithmetic operators. These are used to perform basic mathematical operations like addition, subtraction, multiplication, and more. Next, assignment operators. These are used to assign values to variables. These are great for writing clean and concise code. Next comes comparison operators. These are used to compare values, and they return a Boolean result, true or false. You'll often use these in conditional statements and loops. Logical operators. These are used to combine conditional statements which will help you build powerful and flexible conditions. The last 2 types are something you might not have seen in other programming languages. Identity operators. These check whether 2 variables refer to the same object in memory. Remember, double equals to checks for value, while is checks for identity. Last, membership operators. These check if a value is present in a sequence, like a list, string, or tuple. These are super useful when working with lists or strings. Let's explore how Python handles memory for us, so we don't have to worry about the complex stuff. First, automatic memory management. Python has automatic memory management, which means you don't need to manually allocate or free memory like in languages such as C or C++. Behind the scenes, Python keeps track of all objects and their usage. When an object is no longer needed, boom, Python automatically cleans it up. Second, reference counting plus garbage collection. Reference counting is a memory management technique used by Python to keep track of how many times an object is being used or referenced. Every object in Python has a reference count. Basically, a number that tells how many variables, or other objects, are referring to it. So, how does it works? When you create an object, Python creates the list object in memory and sets its reference count to 1, since A is referring to it. If you assign it to another variable, now 2 variables, A and B, are pointing to the same object, so the reference count becomes 2. If you delete one reference, the reference count goes back to 1. And when the reference count drops to 0, Python knows that nothing is using that object anymore, so it automatically deletes it to free up memory. This is part of Python's garbage collection process. Now that we know how data lives in memory, let's learn how to control the flow of our code, using conditional statements. In Python, conditional statements let your program make choices based on certain conditions. The if statement. It is the simplest conditional statement. It runs a block of code only if a certain condition is true. Let's look at an example. We'll create a variable called age and assign it a value. For now, let's go with 18. Now, let's check if the age is greater than or equal to 18. If it is, we'll print, you are eligible to vote. Let's run the code, and since the condition is true, it prints the message. Now, let's change the age to 15, save it, and run again. This time, nothing prints, because the condition is false. So, the if statement only runs when the condition is true. If it's false, Python simply skips that block of code. What if the condition is false? That's where the else block comes in. If the if condition isn't met, Python will run the code inside the else. Let's update our code. Now, when we run this with age equals 15, the condition is false, so it prints else part. So yeah, if handles the true part, and else catches everything else when the condition is false. When you have to add multiple conditions, then comes the role of elif. It is short for else if. It checks each condition from top to bottom and runs the first one that's true. Let's say we want to check specifically if someone is a teenager. We can add an elif after the if block with a condition, age greater than or equal to 13. If that's true, we'll print, you're a teenager, but not eligible to vote. So here's how it works. If the age is below 13, the else block will run. If it's between 13 and 17, the elif block runs. And if it's 18 or above, the if block runs. Next, nested conditionals. You can also nest conditionals inside each other to check more complex logic. New condition is, if the age is 18 or above and the person is also a citizen, then they're eligible to vote. So, we'll add another if condition inside the main if block to check for citizenship. Let's also update the age to 25. Save it and run the code. Since both conditions are true, it prints the message from the if block. Key things to remember. First, always use colons at the end of if, elif, and else lines. Second, indent the code inside each block, usually with 4 spaces or 1 tab. Alright, now your program knows how to make decisions. Next up, let's teach it how to repeat tasks with the power of loops. There are 2 main types of loops in Python: for and while loops. Let's check them out. For loop. The for loop is used to iterate over a sequence like a list, string, or range of numbers. Let's see the code. We'll create a list named fruits with 3 items: apple, banana, and cherry. Then, we'll use a for loop to print each item one by one. The syntax is for, then use a loop variable, we'll call it fruit, followed by the in operator and the list name, then a colon. Inside the loop, we'll simply print fruit. Save it and run. See, each item is printed separately as expected. Another common use of for is with the range function. Suppose we want to print the numbers from 0 to 4. For that, we use the range function. Simply write for, followed by a variable name, let's use I, then in range, 5. The range function generates numbers starting from 0 up to, but not including, the number you specify. So range, 5, will give us numbers from 0 to 4. Inside the loop, we'll print I. Save it and run. See, the number 5 is not included, just as expected. Now let's take it a step further. What if we want to start from 1 and go up to 5? We can pass 2 values to the range function, the start and the stop. So, range 1, 6 will give us numbers from 1 to 5. Again, it stops before the second number. Let's see the output. Cool, it's working as expected. If we want to skip numbers, like printing only even numbers, we can add a third value, the step size. For example, range 0, 10, 2. So, it starts from 0, goes up to, but doesn't include, 10, and increments by 2 each time. It will print 0, 2, 4, 6, and 8. So, the range function in Python can take up to 3 parameters. First, start, where the sequence begins, default is 0 if not specified. Second, stop, where the sequence ends, not inclusive, and third, step size, the difference between each number, default is 1. Now comes while loop. While loops keep running as long as a condition is true. Let's see the code. We want to print the counting from 0 to 2. First, we'll create a variable named count and initialize it with 0. Then, we'll use a while loop with a condition count less than 3, which means the loop will run until count reaches 2. Inside the while block, we'll print the value of count and then increment it by 1. Here, the loop keeps printing until count is no longer less than 3. Just be careful. If the condition never becomes false, your loop will run forever. That's called an infinite loop. So, 3 important things here. First, the loop variable is initialized. Second, the condition is set, which determines when the loop will stop. And third, the loop variable is updated inside the loop after each iteration. Now, let's explore loop control statements. Python gives us a few tools to control how loops behave. Break, used to exit a loop early, regardless of the loop's condition. Continue, skips the current iteration and moves to the next one. Pass, a placeholder that does nothing. It's used when a statement is required syntactically, but no action is needed. And lastly, you can even use else with loops. The else block runs only if the loop wasn't interrupted by a break. Let's see the code demonstration for each of these. We'll create a for loop that will run from 0 to 4. Now, let's add a condition. If I is equal to 3, we simply break the loop. So, when I becomes 3, the loop will stop. Therefore, it will print 0, 1, and 2, but 3 and 4 will not be printed. So, break allows you to exit a loop early, regardless of the loop's condition. Now, let's replace the break with continue. This time, the loop will not break. Instead, it will simply skip the iteration when I becomes 3. So the output will show 0, 1, 2, and 4, while 3 will be skipped. Now, let's replace continue with pass. This time, the loop will not do anything when I becomes 3. It will simply run the loop as usual, without skipping or breaking, and will continue printing all values from 0 to 4. While pass seems like it does nothing, it's helpful in these cases to maintain structure and avoid errors. Now, let's see how the else block works with loops. We'll add an else block to our loop and print, loop completed without break. At first, the output will be just 0, 1, and 2, because the loop contains a break when I becomes 3. Since the loop was interrupted by the break, the else block doesn't run. Now, let's remove the entire if block, which contains the break, save it, and run again. This time, the output will be the full series from 0 to 4, followed by loop completed without break. So, the else block runs only if the loop completes normally without being interrupted by a break. Now you know how to make your code repeat itself like a pro. Next up, let's learn how to organize that code better, with functions in Python. In Python, a function is a block of code that only runs when you call it. You can pass data to a function, and it can return data as well. Let's dive in. To create a function in Python, you use the def keyword followed by the function name. For now, let's name it greet, and then add parentheses. Inside the function block, we'll add a print, hello techies. Now, if I call greet function anywhere in my code, it will run that block of code. Simple, right? So, this block is called function declaration, and this is the function call. You can also pass arguments to a function to make it more dynamic. So, let's add an argument called name, and we'll use it inside the function to print a message using a Python f string, like hello name. And while calling the function, you just pass the name, like this, greet, techies. If you don't know what f string is, it is short for formatted string. It is a way to insert variables directly into strings using a cleaner and more readable syntax. It was introduced in Python 3.6 version. You put in small f or capitalized F before the opening quotation mark, and then use curly braces to insert variables or expressions. Let's jump back to functions again. Functions can also return values instead of just printing them. So, let's create a new function to add two numbers. We'll define it using def add a, b, where a and b are the parameters. Inside the function block, we'll use the return statement to return their sum. Now, when a function returns something, we usually catch that value in a variable. So, let's call the function like add 5, 3, and store the result in a variable named result. Finally, we'll print the result. Save it and run. You'll see the sum of the two numbers. Important functions naming tips. First, use meaningful names like calculate_total or get_username. Second, use snake case, that is all lowercase with underscores. And third, keep functions short and focused on one task. Python comes with a ton of handy built-in functions you can use out of the box. No need to define them yourself. These built-ins are lifesavers and speed up development big time. Pause the video and check out these some popular built-in functions. Now that we know how to bundle code into reusable blocks with functions, let's level up even more by organizing code across files using modules. A module is simply a Python file that contains functions, variables, or classes that you can reuse in other files. Let's dive in it. To use a built-in module in Python, you import it using the import keyword. Let's import the math module. This is a built-in module that gives you access to a bunch of mathematical functions like square roots, trigonometry, constants like pi, and more. Let's use the square root function. Just write print math.sqrt16, and it will display the square root of 16, which is 4. Now, if you only need one part of a module, you can import it directly to keep things neat. For example, if we only need pi, we can write from math import pi. Now, just print it, and it will display the value of pi, which is approximately 3.14. You can check out the Python doc for more built-in modules. I'll drop the link in description. Now, let's create our own custom module. First, create a new file and name it greetings.py. Inside this file, create a function called say_hello that prints hello followed by the name. Now, create another file and name it main.py. In this file, we'll import the greetings module by writing import greetings. Then, call the function using greetings say_hello and provide parameter values. That's it. You've successfully created and imported your own module. That was your solid start into the world of Python programming. We covered a lot of ground today, from the basics of variables, functions, loops, all the way to memory management and modules. Don't forget to check out the official Python documentation. I'll drop the link in description. If you found this helpful, drop a like, subscribe for more content like this, and share it with someone who's starting their Python journey. Got questions? Confused about something? Or want me to make videos on specific Python topics? Comment below.